We'll go on to the last talk now because we're running short of time.
Yeah.
So our last speaker is Dr. Abhishek Anand, and he'll be speaking on the multi-stage cutting ophthalmic device called the VitRotor. Dr. Abhishek.
Thank you. Can I have the presentation? Okay, fine. So it's not on the main screen. Okay. Hi, everyone. I am Dr. Abhishek Anand. I am Associate Professor at IGMS Patna. And I would be pitching my new concept, that is VitRotor, a new age vitrectomy cutter. Can I have the next slide, please? So basically, we all know that a higher cut rate translates into a more safety for any vitreoretinal surgeon. And the existing vitrectomy cutters are basically work on a respiratory motion of pneumatic cutters, which limits the number of cuts per unit time. Can I have the back slide, please? Yeah, and the upper threshold currently is around 10,000 cuts per minute. And increasing the cut rate in a gluten-like cutter decreases the duty cycle. So we have two problems. One is the number of cuts that we want to increase. So in order to break this threshold of barrier, we propose that a rotating cutter can break this threshold which has been put by the reciprocity cutter or the gluten cutter, and we achieve a safer and faster removal of the vitreous gel. We want to achieve that, and what we do is that if you use a gluten type cutter, you can't do a multi-stage cutting. So if you use a rotatory cutter, then you can do a multi-stage cutting. So the innovation is that we made a casing that will house an electric rotating actuator, and which will be connected to the cutter through a coupler. The operator will switch the handpiece, which will start the disposable motor. We initially want to achieve somewhere around 30,000 cuts per minute. The disposable motor will rotate at a multi-point cutter, and this multi-point cutting refers that the cutting is not done at the tip, but also in between the shaft also. And the best part is that it will have a modular design. So if any part falters, then you can just replace that part instead of changing the whole cutter. So these are the parts of it. There is a back blade, then you have the DC motor, then you have the aspiration line, the motor housing. They have the hollow shaft, which is outside, and then we have a solid cylinder, which is inside. So this is an animated design of this. So basically, this cutter has an outer housing, and this inside there, and this is the main part, which is the solid cylinder. And this solid cylinder, if you see, there are two cutting parts. One is in the middle, and another is at the end of the cutter, which is like a traditional. And there is a DC motor which drives it. And once you have the encasing of the solid cylinder, and then like a typical cutter, you can put it in the eye, and you start aspirating it, and then it starts aspirating. The only difference is that it will cut at 2 points. You can add more points if you want. Now this is the main design of the shaft that we have proposed for our patent filing. So we can see the 2 points of cutting. One is at point A and one is at the point B. So overall, what are the expected benefits is you want to achieve ultra high cut rate, you want to make it instrument cheap, you want to have more durability, low carbon footprint, and universal availability. So till now, we have crossed some parts of the journey like design and simulation, prototyping, and the IPR. So this is one of the first prototype, which we used a Goda 23 gauge vitrectomy cutter, which won the first prize at the just concluded IIT TechMet. And we used the actuator and the coupler to show that it can actually work. This is our patent number, which is under the process. But overall, it's a very long road, and the main hurdle is the fabrication and the big budget that you require for it. So we are working on this. This is just a step from our ICMR proposal that we have submitted for around 75 lakh of the budget that we want for ICMR to support it. And we see that the fabrication process itself can take 36 months itself. So, and these are my partners in my journey. So thank you for listening to me. Thank you.
Why multi-level cutting?
So multi-level cutting is that when we go for a more finer gauge, then the vitreous sometimes clogs it. It decreases the cutting, and it sometimes inhibits the extrusion. So the point is to more faster removal. And the point is that we are getting this in a rotatory cutter. You can do that. It also acts as a support in the middle of the shaft also. So these are the two part of benefit.
So you are saying the vitreous which is cut by the tip of the probe,
Yeah, yeah.
as it traverses through it, will keep getting cut.
Yeah, yeah,
It's
emulsified.
not multiple openings to the external.
No, only
Okay.
tip.
Yeah.
Dr. Abhishek, how do you sterilize it?
Sorry.
The motor is in the handpiece itself.
Sorry.
How do you sterilize it? Motor is in the handpiece.
So it will have. It's not like that it will have like a typical casing. It will be. We are still in the formation, but we think that the whole pressure where we'll hold it